Today I'm going to be talking about lithium banks, specifically budget busing to connect the lithium batteries. Just a small disclaimer, I've actually never made a lithium bank before, so stick around. Maybe watch me set my garage on fire or possibly my car as well. It should be interesting. So for this project, I'm going to be using mild steel because it's budget friendly. I'm going to be using 38 120s or headways that need to be connected in a 4S arrangement in groups of 3. This produces 12.8 volts and can charge on a standard alternator with standard voltage regulation of the 14.8 volts, so you don't need to mess with your alternator or do anything like that, and it'll function properly and fully charge. So I have 12 cells, which will be 3 cells per group and 4 groups, producing 24 amp hours at a maximum discharge rate of 20 C, which works out to roughly 6,144 watts maximum. It won't be running that high. It's probably going to be running around 4,000. So what I'm going to be doing is I'm going to be cutting some steel, drilling the holes to line up all the cells, and then welding the steel together. So I'm going to go through some of the products that I have, my battery management system board, the steel, the welder that I'm going to be using, and sort of the spacing and length and the logistics of getting the bank together and getting the busing assembled so that I can hook all of this stuff up and get it running in my car. So yeah, let's take a look at some of the pieces I'm using. If you're interested in sticking around for the whole video, that's great. If you like my videos, subscribe. That'd be fantastic. I do lots of other videos on sub builds and stuff like that. I'd love to have your support. So starting off right here, I have 3 pieces of 36-inch. It's 3/4 inch by 1/8 inch. So it's fairly thin. I don't want the bolts to have to go through too much, so what I'm going to do is I'm going to stack them so they're 1/4 inch, and then I'm going to drill them set before I weld them together with a 3/8 hole in the top one, and then like a 1/4 or 3/16 hole in the bottom one, so that the bolt will actually only go through, will actually only be compressing on the battery to the lower bar. That way it gets more of the bolt into the battery rather than having to buy new length bolts. So we're gonna get to cutting some of these down to length and then welding them together. This here is the battery management system. It's supposed to get up to 100 amps. I'm not really familiar with these things. Hopefully it works. I don't know if that was the best choice for this project, but that being said, we're going to give it a shot and see how it goes. Hopefully, like I say, I don't set my car on fire or burn my garage or anything like that. The other thing to make note of is that I'm a bit of a mad scientist. I like to kind of do things my own way, and that could be criticized or potentially, dangerous at times. But this here is how we are going to weld the bars together. We're only going to be mostly spot welding. There'll be some continuous stuff. Anyway, this welder cost me roughly $50. Now, what we got here is 4 900-watt transformers with their secondary coils removed and being replaced with, I believe it's a 12 gauge wire. Anyway, I'm not sure. I made this thing many years ago. It's very effective. except it is there's no regulation of any kind, and it is full blast always. It should be sufficient. I know. Why would you make something with that kind of voltage out of or amperage out of wood? It is not. It is definitely combustible, is what I meant to say. Anyway, it plugs into a 208 or 240 plug behind my dryer. So that's how we're gonna weld these things together. I know that thing works because I've used it for many other projects, and I think it will be adequate. Sometimes it's a little bit overkill, like I say, because the power's unregulated. It might just melt these bars to nothing, but we'll see what happens. It should be interesting. So the first thing I'm going to do is I'm going to cut the two short bars for the first three, and then either the positive or negative end of the bank. So these bars will only be directly connected to 3 batteries, and then there'll be another one at the negative end, and then there'll be 3 sets of bars that connect to 6 batteries. So I'll do a quick little drawing and I'll put that on the next clip, and then we will get started cutting and drilling and putting these things together. So this is a 4S arrangement, groups of 3. Power starts at one end and then travels through 3 into a bus bar, through the next 3 into a bus bar, through the next 3 into a bus bar, and then through the next 3 and into the other side of the bank. So that's the length of the first bar on this end is 152 millimeters. So that's going to be the first one we work on. It's going to be have a hole at this end that will be, I believe, 5/16, and then we'll go 3 holes that are we'll start with, let's say, 3/16. I can always enlarge them after, but I can't make them smaller. So we'll start on a bit on the small side. I don't actually have the cells yet; they're in the mail. So we'll start small, and then on the upper bar, it's gonna have obviously the same hole for the bolt to go through for the lugs, and then these holes I'll probably do 3/8, so that the hex bolts just sit inside of those ones. And then I don't know what we'll do. We'll probably tack weld at these locations, and then probably once everything's all held together, maybe add a couple more spots so that they're as secure as possible, and then probably end up doing the whole length. This depending on how the welding goes. If it seems that it's just cooking the metal, we might have to sort of cut back how much we do. But if it's going well and I can get clean welds on everything, then we'll continue welding the whole length, top and bottom, so we have the most sort of path for electrons to travel through to get the power to the amplifier. So that's what I'm going to do now. I'm going to cut the 152s and then mark them for their holes. Now I believe this one is 21, 44, 44, and then this one is 9 millimeters from the end. So that's kind of the layout I'm going with, and then we'll talk about the 2 sets of lower bars and then the center upper bar. So lower bars, upper bar on the next, before we start making those ones. So after sort of drawing the cuts onto the pieces of metal and laying out the lugs and stuff like that, I decided that it would be advantageous to make them the end bars a little bit longer, so we could I could add extra lugs or whatever. So in order to place 2 lugs on there, I had to add like 28 millimeters. So the total length of the end bars now is going to be 180 millimeters, or roughly 7 1/16 of an inch, primarily to accommodate the 2 0-gauge lugs, because the positive side is going to have 3 coming off of it. So just to be extra cautious and have a better better connection for them. That's how we're going to do it. So this is our 2 pieces of 1/8 inch by 3/4, cut to 180 millimeters. I used a angle grinder with a cutoff wheel, and then cleaned it up with a separate angle grinder with 40 grit on it to just clean up the edges. What I'll do is, once I've drilled the holes and welded everything together, I'll file the ends and smooth everything out and clean it up. Take the anti-oxidizing finish off or whatever. So they might rust, but they'll look good when they're new. Anyway, so that's where we're at now. Next step is to mark them for the holes for both busing and for the battery screws to go through. So that's the next thing we're going to do. So we'll start by marking the 2 lugs on here. So that's going to sit like that. Space them out a little bit. Mark the center. Good enough. They're gonna look pretty anyway. What are these? 18 mil, right? So 24 mil. So we want to mark them at 12. Mark them at 12. Now what we'll do is we will switch this. We're going to do the screws in for the batteries from the other side. So the first one's 21. And then from that one, we're going 44, which is going to be a little bit more challenging because 20, 30, 44, 10, 20, 30, 44. Now those will all be 12 mil from. Turn this off. Okay, so now we're gonna have to mark these, punch them, because I don't want to have the drill wobbling all over the place. So we're gonna I'm gonna do that off the bench because it's gonna shake everything, obviously. But we'll come back after I've drilled the first round of holes and take a look. So I got the first round of holes complete. That means I can drill them one plate at a time, because everything will line up now. I got a bit of grinding to do, but yeah, next step is to drill these ones to the 5/16 so that the lugs will bolt on there. Then drill the top ones to 3/8, I think I'm gonna go. And then the bottom ones to, I don't know, maybe 3/16 or something small, so that it's lots of room to drill them bigger if needs be. And then also the upper ones will have enough room for the hex heads of the bolts to sit in. So that's what we're gonna do next. So there's the 2 bars. I got the bottom bar. that I've only drilled out with little holes so I can always enlarge them to suit the bolts that come with the Headway cells. These ones are roughly 5/16. They should be adequate to fit the bolts for those guys. Then I got the top plate with the larger bolt or larger holes for the heads of the hex screws to actually sit in, and then the same ones that line up with the bottom plate. So that's what it looks like. That's what we're gonna weld together. Should be interesting anyway. See how it goes. So I'm just getting ready to weld this thing together. Just another disclaimer. I have some serious safety concerns here. Yes, I will be holding the welding rod in a pair of vice grips. And I will be running it on a dryer plug, off of a dryer plug. So, you know, it's gonna be fun. I do have a proper welding helmet, and I do have my welding gloves, so I'm not, you know, overly concerned about getting electrocuted or anything like that. But you know, just like things blowing up or something. But anyway, we'll see how it goes. So yeah, stay tuned. Okay, bass brothers and sisters, here we go. This should be interesting to say the least, but I will definitely be sitting on this side because we don't want to have this light shining on the camera. Sticking. The gloves on. Be trimming that a bit, but that's okay. That's helmet back on. Gloves back on. Safety first, ladies and gentlemen. now, people. Ooh, I'm setting this thing on fire right now. Gotta love that 240 juice. There we go. It's all welded. Minus a couple of spots that I'm gonna want to add some welds to, but it's very, very welded together. It's definitely some cleanup to do. I'm not a professional welder, as you can see. So, oh, wow, that stinks. Cool. Okay, well, that's it for now, folks. I mean, I'm not, it's hideously ugly, but once I get it all finish all the welding and get it all machined up and clean, I think it'll look pretty nice. It won't be perfect. I don't care. It was $27 for the metal versus buying something like copper bar like this, which is like, I had to mortgage my house to get this bar, but that's okay. So anyway, that's where we're at for now. We will come back and hopefully get all these bars done before the batteries get here. So as it turns out, my welding isn't as good as I would like without practice. So the first attempt ended up warping the metal. I don't know if that's visible, but it doesn't sit flat, so I can't even polish the imperfections out of it because it rocks. The second one worked out very well. So now I'm making a third one, and then that will be the one I use. This is just we'll call it a prototype, but we're not going to use that one. We'll use this one. I'm just drilling the holes, and then I will weld it together and make it look like that. I've been polishing it on the belt sander, and I've been putting the holes in it with the drill press sitting on that awesome chair in my chaos garage. I'm still alive. It hasn't killed me yet. There are some safety concerns. This just arrived in the mail today. It's the last piece of the puzzle for the current build that I'm doing. You can probably guess what's in there, but we're going to take a look and see if everything survived the trip. Yeah, let's open it up. Very nice. That, my friends, is what we were hoping for. Let's just take a quick look. Excellent. It's 10:39 at night. I just finished drilling the bottom plate and the top plate. Probably burn myself. It's pretty hot. Gotta do some polishing, but this way, those will get welded together for the batteries to clamp onto. Then these will be your positive ends, and I gotta make 2 more of these for bar 2, 3, and 4. These being 1 and 5 for the 4S. So I'm going to weld these together. So these are pretty hideous. However, they will work for the time being. I do intend on replacing them with copper bars, but there's a bit of work ahead of me for that because copper's harder to work with, even though it's incredibly soft. That actually might be part of the problem. Anyway, I'm having trouble breathing in here due to all the smoke from all the welding that I had to do to get these last 3 bars done. They like, again, they're not pretty. They're not pretty. They're pretty hideous, actually. So I guess from that point of view, they are pretty something. They're pretty hideous. But anyway, we're gonna this is gonna be the first time I assemble the whole 4S 3P bank of Headways, just to sort of see what it looks like, because I've never made one before, and so I'm gonna take them out of the box and put them together and give it a voltage DMM, and then probably break it back down and clean up the bars and get the drill holes for the balancers to attach to, the wires from the balancer chip to attach to. And then figure out if I'm going to make some kind of covers for these, because I don't really want exposed busting bars in my car, even though there's carpet everywhere and all that whatnot. Anyway, we'll set up the camera and put it all together and see how it looks. Not the prettiest bars I've ever seen, but they'll work. Let's give that a reading. Let's see what we got total here. That should be 3.4 times 4, obviously. So 13.2 volts. Sorry, that's horrible math. 13.6 volts. Oh yeah, that's nice. There you have it, my first lithium bank. It only took me 25 minutes to assemble it. That is brutal. Anyway, we will make some videos once I get it in the car, and hopefully, you know, I don't blow anything up or set my car on fire or anything, but it seems to be pretty good.